Hello everyone, in this video we'll be solving problem 94, binary tree in order traversal. The problem statement is, given the root of a binary tree, return the in order traversal of its nodes value. In example number 1, we have total of 3 nodes in the binary tree. So when we do an in order traversal for this kind of a binary setup, the output is 1, 3, 2. There are 3 ways of binary tree traversals, but in this video we'll only talk about in order. For in order traversal, we always go to the very left side of the tree, process that node, then we process the parent, and then we process the right node. So for this case, if we start the traversal, we start from node 1, but we will not be processing that. We'll go to its left. We'll check if node 2 have any left leg. If yes, then we'll go down deeper. We got to 4. We'll check, does 4 have anything? No, it does not. So we'll process 4, or in this case, we'll write it to our output. So the first entry will be 4. Then we'll check if it have a right node. No, it does not. So we'll do nothing. Then we'll go to its parent and process that. So which is 2. So we'll write 2 to our output. Check its corresponding right. There is no right node or right leg. So we'll go to the parent, process this node. We'll have 1, then go to the right. Now, when we are at this position, we'll do the same approach that we did earlier. So first we'll process the left leg, then the parent, and then the right. From 3, we'll go to 5. We'll write 5 to our output. Go to our parent, write 3, then go to the right, and then write 6. For in order, we first do the left, then parent, and then right. This is the way in order traversal works. So the output for this binary tree is this. Let's try to apply this logic to example number 2. So we'll start from 1. 1 does have a left, so we'll go to 2. It also has a left, so we'll go to 4. This one does not have a left leg, so we'll process the parent leg. The first number will be 4. It does not have a right, so we are done with this node. We'll go to the parent. We'll process this node. So 2, then go to the right. 5 does have a left leg, so we'll go to the left leg. 6 does not have any left, so we'll write 6. It does not have anything on its right, so we'll ignore. We'll go to the parent. We'll write 5. Then we'll go to its right. We are at 7. It does not have any left, so we'll write 7. It does not have a right either, so we'll go to the parent. 5 is already processed, so we'll go up. We are at 2. 2 is also processed, so we'll go to 1. We have processed 1's left leg, so we'll write 1. Then go to the right. Look at 3. Does it have any left legs? No, so we'll process 3 or write it. Go to its right. 8. Does 8 have a left? Yes, it does. So we'll write 9. Then we'll go up, go to 8. This will be our output. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is my C# solution. This is a very simple solution. In the main method, I am creating this new variable to maintain or add all of the node values in the right order. I then call this traverse method, passing the root of the binary tree and this results variable. In the traverse method, I am first checking if the node is not null. If the node is not null, then I start calling the traverse method and pass the left leg of the node. This will continue until I have a left leg. After all of the left leg is processed, then I am adding the current node's value to the result array. And after that, I am calling the traverse method but passing the right leg of the node. After this entire iteration is done, I will have all of the values in the results array and returning it on the last line of the main method. This solution beats 100% of the submissions made on LeetCode so far in terms of time complexity, and in terms of space or memory consumption, it beats 70% of the solutions. Thank you for watching this video. I hope you were able to understand my explanation and the source code. The link to the source code is available in the description below. Feel free to check that out. If you have any questions, please feel free to reach out to me. Happy to talk about it, and I will see you in the next one. Thank you.